Good evening, everyone. Am I audible?
Yes.
We'll just wait for 5 minutes for others to join, then we'll start. Okay, so let me introduce myself. Hello, myself Anjali Ramashankar Prasad. I'm a PMRF scholar from IIT ISM Dhanbad. I'm pursuing PhD. So today we are going to start with the assignment discussion session of week 1 on numerical methods finite difference approach. So have you gone through the week 1 session? The lecture videos and week 0 assignment. Okay, so many people joined again, so let me introduce myself again. So myself Anjali Ramashankar Prasad. I'm a PMRF scholar at IIT ISM Dhanbad. So we are going to discuss week 1 assignment problems, not actually assignment problems but some problems related to that on numerical methods NOC23-ma94. It had been taught by Professor Ameya Kumar Naik and Professor Sanjeev Kumar. Okay. So let's begin with the assignment questions. I hope my screen is visible. Okay. So here is your first question. It says that if the intermediate calculation is rounded off up to 3 decimal places, then what will be the value of 1.3457 plus 2.5725? So it's an easy one. You can go through it and give me the answers, solve it, and say what will be the answer. You just need to round it off up to 3 decimal places. Okay, so I hope everyone might got it. So you just need to add this both and round off what you will get. Okay. So the value after rounding off 1.3457 and 2.5725 to 3 significant digits is 1.346. And the second, when you will round it off, it will be 2.572. Fine. So sum it up, what are you getting? After summing it, you might be getting 3.9182, right? And when you will round it off, so you will get 3.918. Fine. I hope it's clear to everyone. Let's move to the next question. So second question is, the value after rounding 6.235459 to 3 significant digits is. So when you will round it off to only 3 significant digits, that is after decimal points. So what will you get? Along with the value 6. So consider it and tell me what will be the answer. Yeah, it will be 6.24. Fine, because when you will round it off from 5, so it will go to 6.24. So the value after rounding 6.23559 to 3 significant digits is 6.24. Hence, Correct option is A. Fine. Let's move to the next question. Now the question says that if the exact value 3.141 is approximated by the value 3.14, then the relative error in the approximation is. So you need to find the relative error. So exact value is given 3.141 and approximated value is also given 3.14. So find relative error. You might be knowing the formula for relative error. That is modulus of error value upon modulus of true value. So calculate it. Calculate and tell me the answer. So answer is C, 0.0003. You can see what is the formula for relative error. That is modulus of error upon modulus of true value. So here true value is equals to 3.141, and when you will calculate error, that is when you will subtract the approximated value from exact value, so you will get 0.001. Fine. So just put these values in this formula and you will get the relative error, that is 0.003. Have you all got it?
Yes.
Okay. So let's move to the next question. So next question is the condition number of the coefficient matrix of the following linear system, that is 2x1 plus 3x2 is equals 1, comma x1 minus x2 equals 2 under one norm is. So you have to calculate the condition number.
4, I think.
Okay, let others calculate it. Yeah, someone want to say something?
Ma'am, one norm means we have to calculate the norm by the maximum of column wise, right?
Yes, column wise.
Okay.
So have you got the answer? Okay, what is the answer? Answer will be 4. Fine. So how we get it? The system A is equals to matrix 2 3 1 minus 1. Okay, so when you will calculate norm A1, you will get max of columns. So max of column 2 plus 1, and from second column it is 3 plus 1. Okay, so you will get it as 4. Now you need to calculate A inverse. So for A inverse you will calculate its determinant. So you'll get 1 by minus 5 times A, that is, here it will come minus 1 by 5 times, it will be replaced. So finally you will get A inverse as 1 by 5, 3 by 5, 1 by 5, minus 2 by 5. Now you have to calculate A inverse norm 1. So we will get max of summation column wise. So 1 by 5 plus 1 by 5, comma 3 by 5 plus 2 by 5. So we'll get it as 1. Fine. So conditional number K1A, that is with respect to norm 1, it is norm 1A into norm 1A inverse. So you will get it as 4 into 1, that is 4. Hence correct option is A. So anyone has doubt in this, how it came? I hope it is clear to everyone. Shall we move to the next question? Anyone has doubt in this? Okay. So next question is, here is the next question, question number 5, that is, consider the following matrices. M1, it is given by this -2 0 5 0 1 2 0 0 0, and M2 is equals -2 0 5 0 1 2 0 0 1. M3 equals -2 0 5 0 1 2 1 1 6, and M4 is equals -2 0 5 0 0 2 0 1 0. Okay, so you have to find which of these options is correct. So only M1 is in row echelon form, so you have to find which matrix among this is in row echelon form. So find it. Is it only M1, or only M1, M2, M3, or only M1 and M2, or M3 and M4? So what will be the answer? You have to check which of these matrices are in row echelon form. So for row echelon form, what we need to check, that in the matrices, the lower terms should be 0, that is below the numbers, lower triangular matrix. So it will be M1 and M2. Fine. So the correct option is C. Here you can see there is 1 below over here. That is, in row echelon form, actually we check that whenever there is a number, after that number, if 0 starts, then all the numbers below that should be 0, and preferably lower triangular matrix of values should be 0. But here you can see, here it comes 0, then it is 1. So this is not in row echelon form. Here also 0 1 1. So this is also not in row echelon form. So only options are M1 and M2. Fine. Is there any doubt? Yeah.
Ma'am, in this question, we will consider only the ones which are already in row echelon form, or which can be transformed into row echelon?
No, which are already in row echelon form.
Okay. Like in the M4, it can be transferred by a row operation. So that was I was asking.
No. Here they are asking that among these options, which one is in row echelon form. Fine.
Okay.
So let's move to the next question. So next question is, it's a little bit lengthy, so you need to solve it, and I hope everyone will solve it. So question is, the approximate solution of the given system of equations, that is 4x1 plus x2 plus x3 equals 2. Second equation is x1 plus 5x2 plus 2x3 equals -6. Third equation is x1 plus 2x2 plus 3x3 equals -4. Correct up to 2 decimal places after 2 iterations of Gauss-Jacobi method with initial solution taken as 0.5, -0.5, and the x3 value will be -0.5. Fine. So you need to transform this system of equation in a matrix form A, B, and you have to solve it through Gauss-Jacobi method. Okay, and initial solution is given as 0.5, -0.5, and -0.5. So I hope everyone knows Gauss-Jacobi method. Okay, so Ayush is saying that we have different coefficients for this question in our assignment. So here I didn't get your question. Here also we have different coefficients.
Actually, like the assignment in which we are doing the system of equations are different. Like it is 5x1 plus 3x2 minus x3 is equal to 5.
Yeah, it's fine.
X1 minus 5
Uh,
equals
Actually, these sessions are
and
like
3. Yeah, ma'am.
we have to discuss the similar type of questions, not exactly those questions. Okay.
Okay. Okay.
So we will be solving some similar questions which will help you to solve the assignment questions. Okay. So please
Yes, ma'am.
solve it and tell me the answer. For this, you have to form the A matrix that will be with coefficients 4, 1, 1. Second row will be 1, 5, 2. Third row will be 1, 2 and 3. And B matrix will be 2, minus 6 and minus 4. So decompose A as L, U and diagonal matrix and apply the Gauss-Jacobi method. You have to do 2 iterations, fine? So let me know when you will complete your first iteration and we will see the answers. If anyone has doubt in solving, you can ask. So have you started? You have to decompose the matrix as L, U and D and calculate H using that. That will be minus D inverse into L plus U. If anyone has got H value, you can share it or can say what you have got the value for first iteration. H value I mean minus T inverse into L plus U matrix. Has anyone got the first matrix H? What is D inverse? A matrices four, one. Yeah, inverse of the diagonal matrix of A. What you have got? You can respond it. So you will get D inverse as, what is the diagonal matrix? It will be only diagonal elements, that will be 4, 5 and 3. Fine. So its inverse you can easily calculate it as 1 by 4, 1 by 5 and 1 by 3. Right? D inverse will be the diagonal elements matrix of 3 cross 3 with entries 1 by 4, 1 by 5 and 1 by 3. Now you have to multiply this D inverse with the matrix L plus U. Am I not audible? Okay, just a minute. I'll solve the issue. Just give me 2 minutes. Meanwhile, you can solve the question. I hope you have got H matrix for the first iteration. Let me know the value. You can unmute yourself and tell me the answer. Are you solving? Yeah, Sumit. Sumit. Okay. Solve it and let me know the first iteration values. Is my slide visible? Okay. So I hope you have got the first iterated value as x1 value will be 0.5, x2 will be minus 1.2 and x3 will be minus 1.33. Fine. And this was the Gauss-Jacobi methods formula that you have to apply to calculate each iterations. Just compare your answers. And if you have doubt in any step, you can ask. Are you getting the first iteration x1 equals value? If you have stuck anywhere, you can ask. Yeah, anyone has doubt, you can say. Unmute yourself and ask. Voice is not audible. Have you got the answer? Anyone? Okay, so just start solving it. So first of all, your A matrix will be, just check, your A matrix is what? Row wise I'm saying 4 1 1, then 1 5 2, then 1 2 3. Fine. Mohan? Yeah, can you please unmute yourself and discuss how you have solved it and what are the problems you are getting? Anyone, can you unmute yourself?
Hello, ma'am.
Yeah. Sumit.
Hello.
Yeah, Sumit. Devashish. Hello.
Ma'am, I am audible.
Yeah, you are audible. Yes, Sumit, you are audible. Am I audible now?
Yes, ma'am.
Yeah. So what you have got, A matrix, it will be 4 1 1 1 5 2 1 2 3, right?
4 1. Yes, ma'am.
Yeah. So the L matrix will be lower matrix with 1 1 2, and upper matrix, that upper triangular matrix, you have got it. Then D inverse value, what is that? D inverse will be only the diagonal elements with 1 by 4, 1 by 5 and 1 by 3, right? Hello?
Yes, ma'am.
Yeah, so
Ma'am,
diagonal. Hello. Am I audible?
yes, ma'am.
Yeah. Okay.
Ma'am,
So
how to find the lower and plus because there is no.
lower triangular matrix will be, first row will be 0 elements, then second row will be 1 0 0, and third row will be 1 2 0. Fine.
Yes, ma'am.
Yeah, and upper triangular matrix will be
Yes,
0
ma'am.
1 1 0 0 2 0 0 0. Fine. Then the diagonal matrix will be, only the diagonal elements will be there and rest of the elements will be 0. So you'll get 4 0 0 0 5 0 0 0 3. Fine.
Yes, ma'am.
Okay,
Yes,
so
ma'am.
now you have to calculate D inverse. So if there is a diagonal matrix, so you can directly calculate its inverse by taking the reciprocal of the
Right,
diagonal
ma'am.
elements. So you will get 1 by 4 0 0, then 0 1 by 5 0, and 0 0 1 by 3. Fine.
Yes, ma'am.
Okay, now you have to multiply the D inverse matrix with the matrix L plus U and with minus sign. So just multiply this both matrices. So minus D inverse matrix will be the diagonal inverse of diagonal matrix that you got, and L plus U will be just add the terms of lower triangular matrix and upper triangular matrix. That will be 0 1 1 1 0 2 and 1 2 0. Fine. We are calculating this first term. So D inverse I have explained,
Yes, ma'am.
and L plus U matrix will be 0 1 1 1 0 2 and 1 2 0. Fine. Are you getting it? Now just multiply this though.
Yes, ma'am.
Okay, multiply these two matrices, and have you multiplied it? Just multiply it, and then we can cross check what is the value. So you will get it as matrix. I'm saying the row elements. So minus of 0 1 by 4 1 by 4, then second row will be 1 by 5 0 2 by 5, and third row will be 1 by 3 2 by 3 and 0. Are you getting it?
Yes, ma'am.
Okay, so this is what our first term, minus D inverse into L plus U. Now we have to calculate the second term, that is D inverse into B. So D inverse matrix you already have, just multiply with the B matrix, that is the column matrix 2 minus 6 and minus 4. Okay, so you might have got a column matrix of, first element will be 2 by 4, second element will be minus 6 by 5, and third element will be minus 4 by 3. Are you getting it?
Yes, ma'am.
Okay, so now you have to just put the values in this matrix. So you will get x1 and x0. So what is Gauss Jacobi? method says that x1 will be given by minus d inverse L plus u into x naught, right, plus d inverse into b. So just put the values that you've calculated first, then xk, that is x0, take x0 as this 0.5 minus 0.5 and minus 0.5 plus the second matrix that you calculated, and let me know the answer. I hope you are doing it. If you have any doubt in this process, you can ask. Just follow it, you will get it. Just let me know when you'll be done. So what are you getting? First value will be 0.75. Here it is mistake. So first value will be 0.75. Second value is are you getting it? 1 minus 1.1. So second value will be, I guess, minus 1.1, and third it's minus 1.16. Are you getting it? Ayush is saying that he has got 0.75, minus 0.9 and minus 0.833. Is someone getting answer like this? Ayush, you can proceed for the next iteration and check whether you are getting x2 value. So what are you getting after the second iteration? Are you getting the answer same as 1.066, then minus 0.883 and minus 0.85? Or is it coming different? Anyone got the answer? So after first iteration, the correct value will be 0.75 minus 1.1 and minus 1.16. Okay. So take 0.75 so this will be your, I have written in the chat box, this will be your first iteration value x1. So the second iteration, you just need to replace here x0 term with x1 and rest of the matrix will be same, and you have to calculate x2. Okay, I guess it's taking a little bit time. Are you solving it or shall we proceed to the next question? Okay. So you just try to get to the answer. Let's move to the next question. So next question is, suppose you have been given a matrix A which has row elements as 1, 3, 2, second row element are 1, 1, 3, third row elements are 2, 1, 3. Reduce into the matrix B by applying row operations R3 minus 2R1 and R2 minus R1. So you have to reduce this matrix by applying these two row operations, and then you have to find the sum of the diagonal elements of A minus B. Okay, so this is your matrix A. You have to form matrix B by applying this row operations, and then you have to sum the diagonal elements of A minus B. Calculate it.
This is 7.
7.
Yes.
Everyone has got the value?
Yes, answer is 7.
Okay. So correct option is 7. Here we have the matrix A. So after applying the first row operation, that is R3 minus 2R1, so you will get it as this matrix A1. For getting it, you have to simply do what? You have to subtract the elements of row 1. First you have to multiply it with 2, then you have to subtract the elements from R3. Okay, so first element you will get it as 2 minus Are you getting it? 2 minus 2. So you'll get it as 0.
This one the answer, sir.
Okay. I'm just explaining for the rest of the people. Next element will be 1 minus 2 times 3, that will be minus 5. Then third element will be 3 minus 2 times 2, that is minus 1. Okay. And when you will apply the second row operation, that is R2 minus R1, so the changes will be in the second row. So you'll simply get it as 1 minus 1, that is 0. Then 1 minus 2, that is minus 2. Then 3 minus 2, that is 1. Okay, now you have got your B matrix. So simply you have to do the sum of the diagonal elements of A minus B. So first calculate A minus B and then find the sum of the diagonal elements. You will get it as 7. Fine. I hope it's clear to everyone.
Yes, ma'am.
Okay, so let's move to the next question. So next question is, by using Gauss elimination solution with partial pivoting of solution of the system, that is x1 plus 6x2 equals 3, and second equation is 2x1 plus 3x2 equals 2. So when you solve these two equations by Gauss elimination, partial pivoting, so what will be the solution? Find it. So first we have to do pivoting of the matrix. In Gauss elimination method, we find pivot elements and we do pivoting, that is we make the lower triangular matrix as 0. Okay, So proceed in that way that you will get the lower triangular matrix as 0. After you will get the your pivot matrix, so you have to do the back substitution, right? Solve it and let me know the answer. So what you have got? Are you getting option B? That is x1 equals
Yes, ma'am.
1 by 3 and x2 equals 4 by. Okay. So let's see the solution, how it's to be done. So you have matrix A as 2, 3, 1 and 6. Okay. We have taken first the second equation and then the first equation, and the x matrix will be x1 and x2, and B matrix will be 2 and 3, column matrix 2, 3. Okay, so you have to find the pivot. You have to do pivoting. For that you need to make this element as 0. Fine. So first, to make it first element as 1, we'll divide it by 2, so you'll get 1 and 3 by 2. Then to reduce it to 0, we applied R1 minus R2. Okay, so you'll get the matrix 1, 3 by 2, 0, then 9 by 2, and the x matrix will be x1, x2 equals 1, 2. Fine. Now you have to do the back substitution. So when you will apply back substitution, so first element you will get 9 by 2 into x2 equals 2. So when you will solve it, you will get x2 value as 4 by 9. And when you will use that x2 value, so you can find x1 in the first equation, that is x1 plus 3 by 2 x2 equals 1. It will give you 1 by 3. Okay. So hence you will get the correct option as B. Fine. I hope no one has doubt. If you have doubt, you can ask. Is it clear to everyone?
Yes, ma'am.
Okay. So let's move to the next question. So the next question is the upper triangular matrix U in the following LU decomposition in Doolittle method form of the matrix. You have been given a matrix 4, 3, 1, 2. Okay, 2 cross 2 matrix you have been given. So you have to use Doolittle method and In the LU decomposition in Doolittle method, you have to find the value of matrix U. Okay. Okay. So have you got the answer? It will be A. It's correct. So you will get the upper triangular matrix U as 4, 3, 0 and 5 by 4. Fine. So let me just go through how you will get till this answer. Yeah. Any doubt?
Yes, ma'am.
Yeah. Say.
Ma'am, LU decomposition हम are yeah. I am audible.
Yes, you are audible.
Yes, ma'am. My question is, well, LU means our lower triangular and upper triangular matrix multiple. My question is, first upper triangular and lower triangular discuss it. Yes. You can write in first upper triangle, then after lower triangular.
No. You have to
This-
first write lower triangular matrix, then upper triangular matrix. And
according to the matrix we change.
it's LU decomposition, na? So you have to first write the lower triangular matrix, and in Doolittle method, the lower triangular matrix will be what you have got. When you will decompose,
What?
like while solving in Doolittle method, what we do is we decompose A as L into U. Fine, where L matrix is
Yes,
given by the diagonal elements will be 1 and
Under the
yeah,
lower triangle element.
and lower triangular matrix here as it is 2 cross 2, so it will be L21. Fine.
Yes, ma'am.
And upper triangular value will be 0, and same in U will be having U11, U12, then 0, then U22. Fine.
Yes, ma'am.
So you have to just multiply these two matrices, and on the LHS you have already A matrix, and you have to compare the element wise, compare the two matrices element wise, and find the values of u11, u12 and u22. So you, as you asked that your question was, can we interchange L or U, right?
Yes, ma'am. Interchange of the L.
No,
Greater than
no,
L would
no. You have to write lower triangular matrix then upper triangular matrix,
yes,
because matrix multiplication is not commutative, right?
yes, ma'am.
So
That's
you
it.
cannot write U into L. Similarly, in Kraut's method, you will be doing upper triangular matrix, diagonal elements will be 1, and here you will be having elements. Fine?
Yes,
Yes,
ma'am.
ma'am.
Shall we proceed?
Yes, ma'am.
Yes, ma'am.
Okay. So last question, it is given as, considers a system of equations. You have been given 1 minus a and 1, and the x matrix is x1 x2 equals b1 b2 column matrix, fine, where a is given greater than 0. Then for which value of a Jacobi and Gauss-Seidel method will converge? Okay, so is it when modulus of a will be less than equals 1 or greater than equals 1, or less than equals 1, less than 1 or greater than 1? So for which values of a you can say that Gauss or Gauss-Jacobi or Gauss-Seidel method will converge. Are you getting it? So what is the criteria for convergence of Gauss-Jacobi or Gauss-Seidel method? You have to think about it. So anyone, can you tell me what is the criteria for convergence of this two methods? Anyone? So Sumit is saying that d less than 1, that is modulus of a less than 1. Yeah, Ayush. The convergence criteria is that strictly diagonally dominant. Is it strictly? Is it strictly or just diagonally dominant? Is it strictly or just diagonally dominant? No, it's not strictly.
Strictly.
Yeah, it's strictly. It should be strictly greater than.
Anything.
I mean, the diagonal. It should be strictly diagonally dominant. Okay. So to satisfy that condition, you should have mod A should be less than 1. Fine. I hope it's clear to everyone. Anyone has doubt in this?
Yes, ma'am.
Yeah.
Because I didn't read of the Jacobian and Gauss Seidel method. Can you explain? Because I didn't read of the
Okay. So, like we have solved one question on Gauss-Jacobi method, right?
Yes, ma'am.
Okay. So, through these methods, we can solve the system of equations using Jacobi or Gauss-Seidel method. Okay. So there is formula for iterations through which you will get the values in each iteration, like xk plus 1 at k plus 1th iteration. You will have some formula, like for Gauss-Jacobi we have minus d inverse into L plus U plus d inverse into B.
Yes.
Okay. So you will get the first iteration, then you will calculate second iteration. So what is the criteria that this solutions what we are calculating in each iteration, so it will converge? That like it means that what should be the criteria so that we can move to our answer as fast as we can. Okay, so for that we need the elements in our matrix such that it should be strictly diagonally dominant. Okay, so for being diagonally dominant, this modulus of A, this A terms should be, as it is 1, so it should be less than 1, right?
Yes, ma'am.
Okay. So whenever there is a convergence criteria, so you have to just check how you can make the diagonal elements the matrix diagonally dominant, strictly diagonally dominant. Okay. Okay. So these are all the questions, the 10 questions we have discussed for this session, and if you have any doubts, we can discuss it now. Okay. So regarding the session, do you have any doubt or any in any of the questions you have missed?
Ma'am, one question.
Yeah.
And
Yes.
one more question. The coefficient, the number of coefficients and
Number of?
four.
Question number
Silver.
4.
Norm question.
Yeah. Say.
Yeah. Yes, ma'am. I understood. It's what dealing. But my question is the four coefficient number means third means which I did not get.
Coefficient numbers?
Means the condition number of a coefficient
Okay.
matrix
Okay.
means what are the same?
Let me explain it again. Okay. So the condition number of the coefficient
Yes, ma'am.
matrix. First of all, what will be our coefficient matrix? through these two equations you will get the matrix A. So 2, 3 for the first row, and for second row you will get 1 and -1. Fine. Are you getting it?
Yes, ma'am. Yes, ma'am. I did.
Got the answer?
So, ma'am, means my question is the
Okay, conditional number.
of
Okay.
because what are the because the process I understood, but to condition in the matrix, what are I did not get.
Okay, so condition number, actually we calculate condition number to check that do our matrix has the solution, like does it exist or not. Okay, like when we have large calculations, so we check through condition number that either matrix is well behaving or not. Okay, there are two terms, like is it well or not satisfying with the, like if you will change the coefficient terms over here, is it giving you large differences in your output or slight differences. Like when we form our equations, when we solve it, we expect that there should not be large difference when you disturb your coefficients over here. Okay, sometimes what happens when you manipulate your coefficients on LHS, there is a very large difference in your outputs. Okay, so that situation is not well defined for our solutions. Okay, so for that thing we calculate the condition number, and there are some conditions like it should be if it is less than 1, so what it is, and greater than 1, so what it is. So in that way we can define it, is it well defined or not. Okay, for that we use condition number.
Yes, ma'am.
Any more doubts? Anyone has doubt? So can you please run through the different types of norm that we need to know? Okay, so there are you might be working with norm 1, that is maximum of the column elements. Okay, then there could be norm 2 also. So norm 2 you have here, as we in norm 1 we are using max of all the summation of the column elements. In norm 2 what we do is we find the summation of square of the terms and then we take the square root. Fine. and for you can generalize it to P, condition number like norm P also, and there is norm infinity, that is max over I summation from j equals 1 to n and modulus of aij, that is you have to sum over the column elements and you have to take the max. Okay, so these are the basic norm you will be using, but generally you will be using norm 1 only. Okay,
Ma'am, what is the norm called in which we have to take the summation of the row values?
um, you won't be using it as summation of the row values, right?
Yeah, like
L2.
in norm one. Even like in norm one, what we did that the summation of the column values
Okay, so you
of
are
that
asking
matrix.
for the when we will take the summation as row values.
Yes.
That
Yes,
will
ma'am.
be
Is there any
L.
name for that?
Yeah, it will be L2 norm.
Okay, okay.
Okay. So for
Yes, ma'am.
max
Yes.
you have L infinity, and for row summation through row you will be L2, and for column you will have L1,
Okay.
and you can generalize it to P, LP norm. Okay. Any other doubts? Apart from this, do anyone have doubt? Sumit? Okay. Anyone else? Any questions related to the assignment problems resolved today? Okay, fine. So thank you for joining the session. I hope it helped you. The only question that was bit lengthy was of Gauss Jacobi, right? So you can try to get through the solution, and thank you for being the part of the session. I hope it helped you all. If you don't have any doubt, you may leave.
Thank you, ma'am.
Welcome everyone, and I hope next sessions will be more interactive and I can fix some problems or issues that we face today. Okay.
Yeah.
Yeah.
Ma'am, which book is the best?
For
I read a number of books, some of books, but which book is the best?
a Jain and Iyengar you can follow.
Really?
Numerical Methods by Jain and Iyengar. You can follow it. Shall I write in the chat box?
Yes, ma'am.
It may help you,
Thank you.
yeah, this book is good. You can follow it for most of the topics it's covered in it. Anyone else want to discuss? Thanks again, everyone. It was being nice. You have all been a very good. Yeah. Devashish, do you want to say something?
Yeah. It is the right of N.K. Jaina, S.R. Linder, and R.K. Jaina. So, okay.
What? Yeah, R.K. Jain and S.R.K. Iyengar.
I saw it before, and
Yeah, it's R.K. Jain
Jaina.
and S.R.K. Iyengar.
Yes, sir.
Yeah, it's a short form, like Jain and Iyengar, we can say it.
Bingo. Okay.